Students, now in today's video I'm going to explain you how to draw the shear force and bending moment diagram for a cantilever which is carrying a partial UDL over the partial span of 4 meter, and there is a point load 20 kilonewton at the free end. Okay, now I'll call the beam as capital A over here, and let us take this point as B, and let us call this point as C and D. Now what I'm going to do here is just let me consider a section in between B and C, or let us consider a section between A and C, and let us call the section as 1 and 1. The section 1 and 1 which is located exactly a distance of x from the free end. Now shear force at any section, let us calculate shear force at any section 1 and 1 will be equal to plus 20 kilonewton. That means shear force at point A, it will be equal to plus 20 kilonewton. According to the definition of shear force is the algebraic sum of all the unbalanced vertical forces acting towards right or left side of the section. I am considering right side of the section here. Towards right side we have only 120 kilonewton which is acting downwards. Right side downward should be taken as positive as per the sign convention. So I am taking this one as positive. This is plus 20. Now same thing again, as there are no other forces in between A and C, shear force at point C will also be equal to plus 20 kilonewton. We got two values here, shear force at point A and shear force at point C. Similarly, bending moment at any section 1 and 1. Towards the right side of the section we have only 120 kilonewton which is pushing the beam in the downward direction. It should be taken as negative. Minus 20 multiplied by x. So bending moment at any section x is equal to 0. That means bending moment at point A, it is equal to 0. Substitute x is equal to 0, you will get bending moment at point A, it is equal to 0. Similarly, bending moment at any section x is equal to 2 meter. That means bending moment at point C, which is equal to minus 20 multiplied by 2, which is minus 40 kilonewton meter. Minus 40 kilonewton meter. So bending moment at point C, we got the value as minus 40 kilonewton meter. Just remember these two values, minus 40 kilonewton meter. Bending moment at A is 0, bending moment at point C which is equal to minus 40 kilonewton meter. Next, let us consider a section in between D and C. I am considering a section over here. Now this section, let us call this one as section number 2 and 2. This section is again located at a distance of x from the free end. Now shear force at any section 2 and 2 will be equal to algebraic sum of all the forces which are acting towards the right side of the section. Now towards the right side we have 20 kilonewton acting downwards, and 40 multiplied by x minus 2. This distance over which the UDL is acting is x minus 2. So let us start with 40 multiplied by x minus 2. This is plus 40 multiplied by x minus 2 is the UDL which is acting over a span of x minus 2, and 20 plus 20 kilonewton. Now shear force at point C, or at a distance of x is equal to 2 meter. Already we have calculated shear force at point A, no need to calculate for point A. Let us start from point C. So shear force at point C will be 40 multiplied by 0. 2 minus 2 is 0 plus 20. So this will be equal to plus 20 kilonewton. So shear force at point C is plus 20 kilonewton. We got the same value as the previous one. Next, let us calculate shear force at a distance of x is equal to 6 meter. That means shear force at point D. So this is 40 plus 40 multiplied by 6 minus 2 plus 20. So shear force at point D, right, it will be 40 minus, this is 40 multiplied by 4 and 20, it is 180 plus 180 kilonewtons. So we got shear force at point D. Similarly, let us calculate bending moment at any section 2 and 2. Now bending moment at any section 2 and 2 will be equal to, so both the forces are acting downwards and they are pushing the beam in the downward direction. So we can calculate this thing as minus 20 multiplied by x minus 40 into x minus 2 multiplied by x minus 2 divided by 2. So this can be written as minus 20x minus 20 times x minus 2 square. bending moment at a section of x is equal to 2 meter. That means bending moment at point C. So it will be equal to minus 20 times 2 minus 0. So this is minus 40 kilonewton meter. So bending moment at point C, it is equal to minus 40 kilonewton meter. We got the same value as the previous one. Similarly, I'll take a section in between B and D. I'm just taking a section in between B and D. Let us call this one as section 3 and 3. It is again located at a distance of x. Now shear force at any section 3 and 3 will be equal to sum of all the forces acting towards right side plus 20 plus 40 multiplied by 4 meter. So this is 16 plus 20 is 180 kilonewton. So shear force at point D is 180 kilonewton, and same shear force at point B, it is also equal to 180 kilonewton. Now we got two values over here. Next, similarly, let us go with bending moment equation. Bending moment at any section 3 and 3 will be equal to minus 20 multiplied by x minus 40 multiplied by this distance over here, it is 4 meter, multiplied by, at what distance it is located again? Half of this distance, right? That means 2 plus 2, 4 meter, 4, x minus 4. So I'm writing down the equation again, minus 20 into x minus 160 multiplied by x minus 4. So bending moment at a distance of x is equal to 6 meter. That means bending moment at point D, it will be equal to minus 20 into 6 minus 160 multiplied by 2. 160 multiplied by 2. So we'll get this particular value as 440 kilonewtons. 440 kilonewton minus 440. Similarly, bending moment at point B, you will get the value as minus 760 kilonewton meter. This one is also kilonewton meter. Now, drawing the shear force and bending moment diagram for the same thing, I am just drawing some baselines over here. The first thing is shear force diagram. Let us draw a horizontal line here. Exactly at point B, we got exactly at point A, we got shear force which is equal to 20. I'm marking 20 here. Shear force at point C, again it is equal to 20. So here it is 20 at point C, and at point D, and at point A at 20. Right, next we have shear force at point C, again it is 20. Next, shear force at point D is 180. So I'm just increasing the value to 180 here. This is 180. And again, there is no difference in the shear force. At point A, again it is equal to 180. So the variation will be linear like this. So everything is positive. Now drawing the bending moment diagram, at point A, it is equal to 0. And bending moment at point C, it is equal to minus 40. Over here I am mentioning 40 kilonewton meter. So variation will be parabolic in between these two things. No, it will be straight line, right? Linearly varying. Next, bending moment at point D, right? It is equal to 440 kilonewton meter, and the equation is square. Then you'll get a parabolic equation over here and a parabolic curve. And for the remaining part, it will be a straight line. We got this one as 760 kilonewton meter. So this is negative value. At point A, D, C, we got different values. So that's it. Thank you. This is how we draw the shear force and bending moment diagram.